All right. So now let's look at the locus definition of ellipse. Ellipse is a set of all points in a plane such that the sum of the distances from two fixed points called foci is constant. So I drew this random diagram. 2 points there it shows with two red values, but let's call these F1 and F2 for foci. Okay, for F1 is one focus, the other one is another one, F2, and there are fixed points. And if we have this point P, which is this green point, okay, this green point, call it P. If we have this point moves around the F1 and F2 in such a way that the distance between F1 and P and F2 and P, these distances, I call it A and B, when you add them, they always remain constant. So let's randomly choose AB1, BB2, that's the distance between the F2 to P and F1 to P. As this point P moves around, if it maintains the same value of 1 plus 2 in terms of distance in total, that means 3, it generates this path, which we call it locus, that actually gives rise to the diagram that is we call ellipse. Okay, that's the locus definition of an ellipse. Regardless of where this point is, as long as maintains within that rule of maintaining the sum of the distances be constant, and the way I wrote it here is the absolute value sign, that means the distance. It's not necessary because distance can never be negative, but in case in terms of mathematical notation, this is actually bulletproof, so that's a way to write it. If this is always constant, this generates this shape that we call ellipse. Okay, so if you remember, the standard equation of an ellipse is given by this formula right there, where A, B are the major and minor axes. And if it turns out that this one is the horizontal major axis, A will be bigger than B. If it's vertical, B will be bigger than A. And the center in here is HK, and we can calculate the value of foci in terms of measurement, and this is given by this relation, plus or minus square root of a squared minus b squared, which is basically Pythagorean, but I'm not going to go into that in this video. But this is the formula for that. The value of the a has to be part of the major axis. So 2a is a major axis. If it turns out that b is a major axis, so this would be flipped over. So whichever is the biggest one, you have to do subtraction and do the square and the calculation. And then to get the foci coordinates, there are two of them. The first one, you have to take the positive root. So you add that to the center. From the center, you add, and then you get that value. So the new coordinate for the foci will be that. The y value, or the, in this case, should not be y, but that is actually k, right? So this is, let me rewrite that as k. All right, the next coordinate will be h minus square root of a squared minus b squared comma k. If it turns out that it is a vertical major axis, so what happens is that the h value stays the same, but you add that to the k value, which is the y coordinate of the center. It's going to look like this. So here it is for the vertical major axis. So here we have h, it will stay the same for the x coordinate of the center, but the k value will be added. Now again, one more thing. Remember, a, b, they are not necessarily for x or y, but in this case, a is the length of the major axis, whatever that is, could be vertical or horizontal. But in this case, for the vertical major axis, this is going to be vertical, right? So A is the bigger one, is elongated vertically in terms of ellipse shape, and this one elongated horizontally. All right, so that is what it is. Do more practice.